I need to record. Okay, we have studied the kinetics of translating and rotating body, and today we'll continue the learning of kinetics of a body doing general plane motion. And actually, no matter its translation or rotation, it's a special case of general plane motion. And we know that, and from a rigid body, and we can write down three scalar equations because the real force system, this is FBD, according to the force analysis. For the rigid body or for the body system, we have the FBD, the real force, including the forces and the moments applied to the rigid body. And this is the KD, we mean the kinematic force and kinematic moment, or sometimes we can call inertial force and inertial moment. The inertial force is actually equal to MAG, and where M is a mass, A is the acceleration of the mass center, G indicates the mass center, and the kinetic moment equal to Ig alpha. Ig is the moment inertia, right? The mass moment inertia, okay, to resist the tendency of rotating. And alpha is the angular acceleration. And no matter its translation, rotation, general plane motion, we can always draw KD this way, right? Sure, for translating rigid body, the alpha is equal to 0, so we can but for so we can have the special case. And so for the FBD and KD, they are actually equivalent force system. We know that for two equivalent force system, they need to satisfy the resultant force equal to each other. The resultant moment about any point should equal to each other. So accordingly, we have sigma F equal to MAG, where sigma F is the resultant force of the real force system, and MAG is the kinetic force for the KD. They should be equal to each other. And this is a vector equation. We can write down it's two scalar equations. Generally speaking, if it's Cartesian coordinate system, so we have the x component of the resultant force of the real force system equal to the x component of the kinetic force. Similarly, likewise, we have the y component of the resultant force from the FBD equal to the y component of the KD. And not only the resultant force of the two force systems should be equal with each other, the moment about any point should also be equal to each other. Generally, we can choose the mass center G to write down the moment. So for the real force system from the FBD, we know all the forces here, including the moment, right? All the forces and moment, the resultant moment about mass center of the real force system equal to the collective moment equal to Ig alpha. Okay, definitely you can write down just any point, because for two equivalent force systems, the moment about any point should be equal to each other. So we can also write down sigma MP, and we mean the moment about point P of the real force system will equal to sigma MKP. We mean the KD moment about point P. So if we want to calculate the moment about P from KD, never forget, not only Ig alpha have the same moment about P, and also the kinetic force also may produce moment about point P, right? We have done this before. Here, you can choose any point, okay, to write down the moment of the two force system. They should be equal with each other. Here, again, the sigma mkp represents the sum of the moments of Ig alpha and mag about point P, because we know that the moment about any point will be equal to each other, to itself. So for the problems of rigid body doing general promotion, sometimes we will meet with the problem involved with the friction force. It will be a little bit more difficult, and because we need to decide not only the magnitude of the friction force, also the direction of the friction force. And moreover, the friction force may be static friction force or the kinetic friction force. Okay, so we need to make assumption and then to check out our assumption sometimes. For example, when analyzing the rolling motion of wheels, cylinders, or disks, it may not be known if the body rolls without slipping or if it slides as it rolls, we're not sure. Okay, we don't know whether it's no sleeping or it's sleeping. So just like here, this is a disk with mass m and radius r is given. The disk is subject to unknown force p, and we have to make an assumption to provide another question why, because for this problem, from the FBD, it's easy. We have the applied force P, we have the weight of the disk, and then we have the supporting force from the ground, normal force, and we have the friction force F. Okay, so here actually this is FBD, and we the friction force. We don't know exactly the friction force, the magnitude or the direction. We make assumption here. Okay, this is FBD, and for KD, so we have the kinetic force MAG, we have the kinetic moment IG alpha, right? So this is kinetic force equal to mass times its acceleration of the mass center. Ig alpha is mass moment inertia about mass center times the acceleration. Accordingly, they are two equivalent force systems. So they need to satisfy they have this equal resultant force, that, and so the projection to the x or y axis should be equal with each other. So we have sigma fx equal to magx, right? So accordingly, we have p minus f equal to mag, sigma fy equal to magy, and so I have m minus mg equal to 0, except the scalar equations of resultant force. We also have the moment equations about any point. Definitely, you can choose mass center. So you can choose mass center. So sigma mg moment about mass center g equal to ig alpha. Here you see we only P and W passing through the mass center, M passing through mass center. So only the friction force actually produce the moment about G from the FBD, right? So the moment of the friction force is R, the moment arm is R, so we have FR equal to IG alpha, okay? So here, one more thing is you say equal to Fig alpha. here somebody say, I don't like to write down the moment about point G. It's okay, you can choose this point as A, you can choose sigma MA, well, equal to IG alpha plus, also never forget when you calculate the moment upon point A, except IG alpha also the MAG will have the moment about point A. So IG alpha plus MAG times R. Okay. So accordingly, from the FBD, the the force P have moment about point A, right? So we have PR equal to IG alpha plus MAG dot R. So no matter you choose my center to write down the moment equation or choose the point A to write the moment equation, we only have three independent equations, right? We only have three independent equations. So if we choose these three equations, we have the unknown friction force and the acceleration of the mass center. The normal force definitely is given, right? So we can find out N directly. And from the FR, so F is a friction force unknown, alpha is unknown. So here, actually, we have three equations, four unknowns, or we have two equations, three unknowns. So anyhow, if we want to find out the solutions, we need to supplement one more equations, right? So here, which one we need to write down to solve out these equations? Somebody say we have done this before. We say because Vg equal to R omega. So accordingly, we have Ag equal to R alpha. But when will this be correct? Why I can write down Vg equal to R omega? If we assume this disk, if we assume the disk is rolling without slipping, that means the contact point A is the IC, the instantaneous center of the velocity equal to zero, right? Only if the disk is rolling without slipping, we can have the Vg equal to R omega, right? Because if A is IC, so the velocity of the mass center will equal to the radius to the IC times the angular velocity. And so G, never forget that G has a straight path line. So take the time derivative Vg will equal to the first time derivative of Vg equal to Ag and omega equal to alpha. So this one only, this one we can only have this one if we assume that the disk is rolling without slipping. Okay, so this equation of motion for this disk is rolling, and so here is FBD. This is KD, and then we have two equivalent forces, same without force, same moment about any point. And so here, if we assume no slipping, and then we can use AG equal to AG equal to R alpha. So four equations, four unknowns we can find out. This time, never use the friction force equal to friction coefficient times the normal force. No, because it's we don't know whether it reached the maximum static friction force or not. But after solving, you need to check whether your assumption is correct or not. Only when the friction force is smaller than the maximum static friction force, that means really the disk is rolling without slipping. Okay, so if you find out FF is actually larger than the static friction force, that means the disk is rolling with slipping. If the uh, if if the disk is rolling with slipping, so this time never use this one because Vg is not equal to omega r. Why? Because the contact port A actually is not icy anymore because it's sleeping, got velocity, so it's not icy. Okay. But we can use the friction force equal to the kinetic friction coefficient, and then we have this, the force equation we still can solve out. Okay, so this is for the disk is rolling, you need to make assumptions. Sometimes, sure, if it's stated that it's rolling without slipping or it's rolling with slipping, so things will be simple. But if not, you need to make assumption and then check out if your assumption is correct or not. Okay. So again, the procedure for analysis will be the same for which body which are translating or rotating. First, we need to establish the Cartesian coordinate system, right? Because you need to write down the scalar equations in x direction, in y direction, right? So first thing is to also you need to calculate the moment about any point. So the first thing is to establish the Cartesian coordinate system. And then we know that it's very important you need to draw FBD for the real force system and then draw KD. So it's very, very important you have the correct FBD and correct KD. Um, when you draw KD, you need to know the acceleration of the mass center and the angular acceleration of the body. Sometimes, if we don't know the acceleration of the mass center, maybe we need to find out. You can make assumption, okay? But anyhow, it's very important that you have the correct direction and sense of the acceleration and angular acceleration. And also for the KD, we need to calculate the mass moment of inertia, IG also. After you have FBD and KD, again, we said they are two equivalent force systems, so they should have the same without force, same moment about any point. So sometimes you can use the moment about the mass center or the moment about any point. When you calculate the moment about any point for KD, never forget, except IG alpha, also the kinetic force also produce moment about this point. Okay, so that's why even for rigid body which is translating, sometimes we still can write down moment equation to simplify the calculations, right? After you have the three equations, and then we can identify the unknowns. If we have the three equations, three more unknowns, so we can they will have unique solutions. So sometimes, just like if we have the friction forces, we need to make assumptions, and then we need to supplement the function about the friction force. Okay. Sometimes we need to use mathematical equations to complete the solutions. Okay. It's very important if you assume it's no sleeping or it's sleeping, you need to check its validity. Okay. And so let's say the procedure. Okay. So again, it's very important that the assumed direction should be consistent with each other. So that means the directions of AG should be consistent with alpha. Okay. The direction of the mass center should be consistent with its angular acceleration. Okay, and also if the friction force is not static friction force, that means if the disk is rolling with slipping, the friction force should be always oppose the motion. Okay. So maybe how can we do this? Maybe we can assume there's no friction and observe the resulting motion, and then the friction force should be opposed to the resulting motion. Okay. A spool has a mass of 8 kg and a radius of gyration. And we know what means radius of gyration. If a radius of gyration is given, so the mass moment inertia should be very easy to calculate, right? Ig will equal to m kg squared, right? Cause of negligible mass, okay, so ignore the mass of the cause of negligible mass are wiped around its inner hub and outer ring. There is no slipping. Oh, it will already state that is actually no slipping. So since no slipping, the contact point should be the IC, okay. So because there is no slipping, so the contact point A will be the IC. We need to find the angular acceleration of the spool. Okay, we need to find the angular acceleration of the spool. So first thing, we know this disk is actually doing general motion, right? It's not translating for sure, and it's not rotating because the axis is actually moving. So it's general motion because the disk is always um, uh, within its plane, okay, moving within its plane. So how to calculate the angular acceleration of the spool? We know that we can have three equations, or maybe we just need to write down the moment equation, because for the moment equation, there would be alpha, right? First thing, again, we need to establish a Cartesian coordinate system. Here, yeah, it's simple. We just only need to have the y coordinates, right? Because in x direction, nothing occurred, right? Nothing happened. So we have the Cartesian coordinates, and then we need to draw FBD, right? We need to draw FBD and KD. So FBD is simple. Uh, the tension force and the weight force. The tension force because here because this force is giving 100 Newton, and so here the tension force is unknown, so we have the FBD, right? This is a real force system on the disk. And for KD, so we have MAG. This is a kinetic force. We have IG alpha, okay? So MAG is a kinetic force. IG alpha is the kinetic moment. But why we know that? Why we know that the acceleration of the mass center, should go up? Why we don't have AGX? Because it's a disk. The contact point A is because it's no slipping, so contact point A is IC, right? And actually, the point G, the distance from point G to point A is always equal to its radius. So that means G actually have a straight path line, okay? So G the path line of G is rectilinear. That's why it's only have AG. One more thing, here we always say the acceleration of the mass center should, the sense of the acceleration of the mass center should be consistent with the acceleration, right? So here AG is going up, IG alpha, Y alpha should be Y alpha should be counterclockwise. Oh, sorry, clockwise. Why? We need to know this. We always say the acceleration of the mass center, the sense of the acceleration of mass center should be consistent with the angular acceleration. Y AG pointing up, and so alpha should be here clockwise. Why not counterclockwise? So that's like AG according to the kinematics. We can choose A as a base point. So AG equal to AA plus AGA, right? AGA, we have the normal and tangential, right? Am I right? And the tangential acceleration is equal to R alpha, right? AGN is R omega square, right? AG relative to A, right? R alpha and AA. So actually we have AG is equal to R alpha, okay? So AG is equal to AGN tau, okay? So we will have, so that means G relative to A should be clockwise. AG can go up, okay? So here you just use this equation to check that AG will be always have the same. We can use this because A is the IC, so we have VG equal to R omega and AG equal to R alpha. Okay, we can use this. You can again the same way. Okay, AG and because relative to A, and so that means AG equal to R alpha G is going up, so alpha should be clockwise. Okay, so here the we have the FBD, we have the KD, and then they should be equal with each other. So we have the resultant force. We can write down the equations of motions. So we have the sigma Fy equal to MAGY. Sigma Fy is the y component of the resultant sense of the real force system. We calculate from FBD. So that's T plus 100 Newton minus the weight and equal to the resultant force of the KD, the kinetic force MAG. Okay, we have this. And so here we have T ungiving and AG we don't know. We can write down another equation about T and alpha. And we can write in the moment because FBD, KD, they are two equivalent force systems. So we can have they should have the same moment about any point. And so we choose the mass center to write down the moment equation. So sigma mg equal to ig alpha. So we have when you calculate the moment about point G, about the mass center, and this force 100 Newton and the tension force will have the moment about G, and 100 Newton is clockwise. We just here we define clockwise as the positive. So it's okay just if you are consistent with the definition of the sense. So the T, the tension force will also produce a moment about G, and it's counterclockwise. So we have the minus here, the T times the moment arm. This one, the left-hand side is actually calculated from FBD. They should equal to the equal to the moment about my center of the kinetic force system. So equal to Ig alpha. Ig, the mass moment inertia, we already calculated here because the mass moment inertia the radius of duration is given, so we can calculate mass moment inertia directly. So we have here, we have T given, we have Ag given, and alpha. So we need to have one more equation. So what will it be? We need to have one more equation. Yeah, we're talking about again and again. We can have Ag equal to R alpha. Just now I have explained why when Ag going up, alpha should be clockwise, right? Why Ag equal to R alpha? Again, because it's no sloping. The already addresses is no sloping. That means the contact point is IC. So we have Vg equal to R omega, and take the time derivative, we have the Ag equal to R alpha. So we have three equations. Solve these three equations, we can find out the angular acceleration of the disk, we can find out the acceleration of the mass center, we can find the tension force also. Okay, so maybe we can, you say, when you take the moment equation, just like we have learned before in status, we can choose any point you want to write down the moment equation, right? And sometimes it's good to write down the moment equation about a point which have unknown force passing through, because unknown force will produce no moment about that point, right? So maybe instead of the mass center, this time we choose A to write down the moment equation. Why we choose point A? Because the tension force is unknown, and tension force passing through point A, so it will produce no moment about point A. So from FBD, the only the known force, the weight 100 Newton will have the moment, right? This one is from FBD, okay, and this one is from KD. From the KD, we have MAG. Let me write down. Okay, MAG, we have IG alpha. So we need to calculate the moment about point A of the KD force system. Never forget, except IG alpha, also the kinetic force will produce moment about point A also. So we have the kinetic force times the moment arm, and so you see they need to be equal to each other. Again, we can supplement the no sleeping condition, we can find out. So it's up to you. The moment equation, you can choose the mass center or any point. Okay, just like here, we choose the mass center, we choose point A to write in the moment equation. You will result in same solutions. Okay, 8 kg spool, the kg is equal to 0.3 meter. That means the radius of duration is given. Is a rough surface and a cable exerts a 30 Newton load to the right. Okay, it's given. The friction force at A acts to the right or left, and the edge should be directed to the right or to the left. So this time you need to judge the friction force and the sense of the friction force. So here, it's a little bit difficult. Why? Because we need to decide whether it's sleeping or no sleeping. So let's draw KD. Let's draw FBD and KD. So first FBD. So this is the force, right? 30 Newton. And then the normal force and friction force, right? The friction force, we don't know friction force. Okay, maybe it's to the left or to the right. We don't know. We just assume it's to the left. So sometimes we need to check. We need to check. Okay, so maybe let's assume that there is no friction force. If there is no friction force about point A, about point A, the moment about point A should be this way, right? So that means under the or my center. So under the action of the force 30 Newton, the spool will rotate about G. I mean, without the friction force. With the spool will rotate clockwise, right? I mean, under the action of the certain Newton, we don't consider the friction force. So if it's sleeping, that means the force, the friction force should be to the right. Am I right? But here, because the angular acceleration is giving, so if it's sleeping, so the point A will have tendency to move to the left. So the friction force should to the right, right? And AG, so AG should be also to the right, right? So this is force sleeping. If it's not sleeping, that means this one is the contact point. Sorry, the contact should be IC. So IG, so AG should be definitely to the right. How about alpha here? So about point A, the static force. So when it's non-sleeping, that means the point A, the friction force should be static friction force. The static friction force also also has tendency to resist the motion of the point A. Again, the point A so has a tendency to move to the left. So the answer should be C. So here, when we judge, the answer should be C. I just here, the friction force at A acts to the right or the left, and AG should be direct to the right, left. We don't know, but if we can assume there is no friction force, and so under the action of this force, we know the spool has a tendency to rotate clockwise. That means A has a tendency move to the left. So if it's slipping, that means the friction force, kinetic friction force, will oppose to the motion. So the friction force should be point to the right. Okay. And accordingly, so we have sigma F equal to MAG. And so accordingly, the resultant force on the spool is to the right. So AG should be to the right. Okay, so this is for slipping. If it's non-slipping, so A is IC. A is IC, right? A is IC, so that means here the friction force should be static friction force. The static friction force again is opposed to the tendency to move. Okay, because alpha is counterclockwise, so AG should be here, right? We have AG should be to the right, right? We know this, we have verified this just in the previous slides, right? Because if it's low sleeping, we have BG equal to R omega, AG equal to R alpha. So AG should be to the right. So again, this AG to the right and alpha is counterclockwise, A still have the tendency move to the left, and the friction force should be the right. Okay, so answer should be C, no matter sleeping or no sleeping. The moment question about point G is which one? Again, you can have FBD and you can have KD. Okay. So maybe we can have 10 minutes break and then we will continue.